Hey Tech Math, here are the guided notes for 7.4, where we're going to be using sine to determine hypotenuse length. So in yesterday's notes, we learned how to find the length of a side using our sine ratio, but we can also find a hypotenuse. We're still going to set it up the same way. We're going to say sine of 30 degrees is equal to opposite over hypotenuse. And we're going to follow the same step we did yesterday. We're still going to multiply by the denominator, but in this case it's an x instead of a number. Well, now I've got x equals sine of 30 equals 4. To get x alone, I need to divide both sides by the sine of 30. And in doing so, these will cancel, and I will just have x equals 4 divided by sine of 30. When I put that into my calculator, again checking to make sure it's already in degrees, I get x equals 8. And that is perfect. No units needed. Let's see it again. Again, we're just setting this up. Sine 70 degrees is opposite over hypotenuse. Multiply both sides by x. Divide both sides by sine. And you get x equals 9 over sine of 70. When I throw that in, I get not a very nice number, so I'm going to round it to 2 decimal places. It's about 9.58. Alright. Quick terminology for you. Angle of elevation is the angle up from line of sight. If you want to put that in your own words, I absolutely encourage you to do so. But essentially, if my little stick figure guy is standing here, this is his line of sight. If he looks up to a bird or something up in the sky, this angle right here is going to be your angle of elevation. It makes sense then that the angle of depression would be the angle down from line of sight. I'll draw my little stick figure again just to remind you. If my vision is here, say he's on top of a cliff maybe, and he's looking down at a boat. I'll even draw you a boat here. It's not great, but there it is. That angle down from his line of sight is going to be the angle of depression. So let's see why that's helpful to us. Why do we care about these vocab words? Mark is flying a kite and realizes that 300 feet of string are out. So let's start drawing a picture. That should be the first thing you do every time here. Flying a kite, so obviously the kite's going to be up here. He says 300 feet of string are out. There's your 300 feet. There's your kite. I don't have to draw the pictures every time. I just think it's fun. And it says the angle of the ground, aka the elevation, is 42.5 degrees. If we know that, how high is his kite off the ground? We're not taking into account his here. We just want to know he is the ground if he's on the ground. So let's set that. If we want to know x, set it up as sine of 40.5 equal opposite over hypotenuse. Multiple sides by 300. You get 300 times 45. Throw that calculator. It's going to be about 202.678. For this one does give us a label. It's a unit. So my final answer is 202 feet. Say how to round it, so we're just gonna do to 2 like we're used to. All right, let's go again. The elevator is 25 long and makes an angle of elevation. So I know that I'm gonna have something on the ground and going up. And that angle of elevation's right here. If you don't know what the elevator is, it's things that you have on a farm. Put the hay bale, and at the bottom of the amp, it has a little conveyor belt all the way up to the top. Conveyor belt comes back down and ends barn. Okay. So because I'm creative here. Here's your barn. It's your little door right assume. And just ignore my off-pitch roof. My elevator, 25 feet long. It says it's aligned with the haymow, which is the top. What's the height of the loft? I want to know this height now from the ground up to the loft. Again, I'm just going to sine of 40 degrees equals opposite over hypotenuse. I'm going to multiply both sides by that number and then throw it in my calculator, and I get that the haymow is about 16.07 feet off the ground. Alright, so last one. An electric pole is to the ground cable. Here's your cable. Attaching it is 30 feet long and makes an angle of elevation of 60 degrees. How tall is the pole? Alright, sine of 60, opposite over hypotenuse. Multiply both sides by 30. We're going to 30 times sine of 60, and I get x equals 25.98 feet. So our electrical pole is about 26 feet tall. Alright, now you've seen it, go do your homework.